Well, it's the beginning of 2022, which can only mean one thing. Our Advent of Code challenge from 2021 is definitely over, and now we have the wonderful task to pick out a couple of winners for the giveaway that we planned. If you recall, in December we said that if you participate in Advent of Code and you solve a couple of the challenges in Kotlin, put your code on GitHub and tag it with the AOC 2021 in Kotlin tag, then you would be eligible to win a couple of Kotlin care packages. If you did participate in the AOC, make sure you watch this video all the way till the end, because that's when we will be announcing the winners, and we also have a little bit of an extra surprise for some of our community members there as well. That being said, we're going to spend the next couple of minutes trying to actually get the over 1,600 people who have participated in the challenge out of the GitHub API and into a Kotlin program so that we can select the final winners. Let's get started with that. If we look on the GitHub topics page for AOC 2021 in Kotlin, we can see there's over 1,600 people who participated in the challenge. That's really exciting. But it also means there's a couple too many people for me to just write on a list, roll a dice, and then just say, okay, those are the winners. Unless someone wants to send me a 1,608-sided die. Please don't. But I was looking around at the GitHub API, specifically the Github Search Api, and it seems that this is going to be my rescuer that's going to save me from writing down 1,600 names on paper. The Github Search API allows me to search for specific items efficiently, which is lovely, especially because it allows me to search for specific repositories. So there's an endpoint called /search/repositories, which accepts a queue, which is the query, which we can use to find the participants. So I just played around a little bit and I found that if you type topic:AOC 2021 in Kotlin, you're gonna get the 1,603 repositories that have this tag attached to them. Likewise, if we combine this together with the actual endpoint that we have here, /search/repositories, we get the following query, which hits the repositories endpoint on api.github.com and gives us 1,602 results. I'm not sure where this small discrepancy comes from. I'm sure GitHub has a reason. Maybe that's estimation, maybe that's caching. I don't know. This is what I'm gonna have to work with. But as you can see, all of this is structured text in the form of JSON. And this is really hard for me to parse and specifically to find the full name of each individual repository. So I think it's time we do some automation with Kotlin. So let's write a small Kotlin program that can make this HTTP request, pull out the 1,602 unique names, and then we can put that into a random list picker somewhere online and determine the actual winners of the challenge. So the only thing I prepared for this so far was a completely empty project as generated by the Kotlin wizards. My tool of choice to make HTTP requests is Ktor because it is not just a server-side framework, it allows us also to write even multi-platform HTTP client applications in a simple way. So we're going to pull the Ktor clients into our application, make our first HTTP request, and take it from there. I'm just going to look at the documentation, navigate to Ktor clients, find the Getting Started with a Ktor Client section, and find which part is the most relevant to me. Since I already created a Gradle project in advance, I'm just going to skip straight ahead to the Add Dependency section. There's 2 dependencies that I need to add to get started, and I'm going to put those right in the dependencies block for my project, and just going to import that. Now you might be wondering, why is there 2 dependencies instead of 1 dependency? And if we actually read a little further, we can see that the documentation has a helpful hint. Ktor Client Core is the core dependency that provides the main client functionality, and Ktor Client CIO is a dependency for an engine processing the network requests. So one of the things actually provides us with all the client functionality, and the other thing actually makes the real HTTP requests in the background. With this, I think we're already well equipped to make our first little HTTP request. So let's move over, remove this boilerplate code, and start writing some Kotlin. Ktor requires us to create an HTTP client, which is a very quick thing. We'll just create a variable called HTTP client and pass the appropriate engine into it. This object of type HTTP client can now be used to make HTTP requests. Not very surprising. So let me just, for example, make the get request that we just made. The generic type of the get function is going to be its return type. For now, we'll just work with a string. We can make this a little bit more fancy in just a moment. And then, of course, we need to pass the endpoint. I'm just going to copy this from my API request that I made in the browser earlier. Looks like this. You can also close this sidebar, and we should be almost ready. There are still some red squiggles here for a good reason, and that is because get is a suspend function, and main, of course, is not a suspend function, but we can change this really quickly and use Ktor's coroutine-based HTTP client from our main function here as well. We also probably want to see what comes back, so we'll just have a variable, let's call it res. I know it's not very imaginative for a result, but we'll just have this here, and we'll print out the result. Run this application and see whether we are actually getting the correct topic results here. And as we can see, we get back a long string of JSON encoded information. And if we scroll all the way to the top, we should be able to see that there's 1,602 total results. Wonderful. So what we need to do is parse this content. Of course, if we wanted to be really hacky and do a quick and dirty solution, maybe we could work something out by using regular expressions, but we might as well just use a simple integration for actual JSON decoding. Because Ktor's clients actually have a wonderful integration with Kotlin Serialization, which is my go-to library for working with JSON. If we look in the Developing Applications tab and go to the JSON section, we can see that there's a couple of small configurations here, but really it's just a few steps that we need to follow to get started. With Kotlin Serialization, we first need to install the compiler plugin. We can find that right here in the setup section, and that's just a single line that we'll add to our build Gradle file. Let me add this here and return to the instructions. The second part is to add the Ktor client serialization dependency. Well, again, that's just a simple snippet that we can copy and paste over here. The only change that we need to make is the Ktor version, which in our case will just hard code at 167. By importing these things, we get the ability to empower our HTTP client with the understanding of JSON. So let's do exactly that. We are going to install what is called the JSON feature, which does exactly what you would expect. And now, instead of returning a string, the HTTP client can instead get a JSON object, for example, directly. Let's run this code again and see what happens. Well, the output looks pretty much the same here. It's still just some JSON code. But the main difference is that res is now a JSON object, which, unlike a string, we can do a bunch of fancy things with. For example, if we wanted to access just the total count variable, we could do so by using the get operator, just adding some brackets. And now our result shows us 1,602. So that's pretty neat. Okay, looking back at the structure, we can see that we get back a JSON object, which has a key called items, which is of a type of a JSON array, which again contains a bunch of objects. And from those, we are only interested in the full name property for now. So let's try to kind of parse this out, or I suppose map this out. First, let's determine the actual items, and that's just going to be, well, the key called items. As you can see, this is a nullable JSON element. More specifically, we want this to be a JSON array, so we'll just use the appropriate extension property. And since we don't want to really worry about nullability in our program, we can just throw an error using the Elvis operator and say unexpected input for items. All right. Looking back, now we want to access the full name for each of the elements inside of the items array and just create a list out of those. The easiest tool to do so would be using the map function. So let's say that our variable repos is items.map. As we can see that those are JSON elements again. Because we know that these are actually JSON objects, so things where we can query keys and get back values, we'll just use this property again and then access the full name property. Now, we can let ourselves be guided by the type system a little bit here. As you can see, the list of JSON elements is the current return type, and it's still nullable. So the first thing we can do is turn this into a string. That already looks better, but it's still nullable. We're expecting every repository to have a name, so once again, we'll just error out in the other case, and we'll just say unexpected format in an item. So now repos is a list of strings, which we can of course promptly print, and we can also check how many we actually got back. So let's run this code and see what happens. Okay, that's 30. That's not 1,600. Huh. So what is happening here is that the GitHub search results from the API use pagination, which means we only get one page back. So we can see here that per page by default is set to 30, and we can up this to 100. Okay, so I'm no math whiz, but with 1,600 results that we want to get out, there's no way we can put those into one page of 100. We're gonna have to work with pagination somehow. So, back to our code. I think it's time we extract a little bit of a function that we can call multiple times. Okay, we'll just call this function fun get repositories, and that'll just take a page, which will be an integer, and that should return a list of string. And so far we can pretty much just move our code over here. Instead of assigning the repos variable, we can just return whatever map creates. And of course, since we are using an HTTP client, we need to make this function suspend as well. Let's shoehorn this back into our main function and make sure that we set the correct parameters for our HTTP client. And you know, in fact, we're going to make this HTTP GET request a little bit more beautiful in general. Because I don't like having all this information just encoded in one long string. And instead, I like to use the parameter function, which we can pass in a block, which pretty much does the same thing. So we can say that for the parameter Q, we are going to pass topic AOC 2021 in Kotlin. Bring this over here. We'll remove the query part. We figured out that there's a parameter called per page, which we can set to 100. And now that we are passing the page parameter ourselves, we can also set page parameter to the variable that we passed to. So with this change, once we run this application, we should now get 100 results at the very least. And that's progress. Yep, that's 100 repos. We're getting there. Okay, now math dictates that we need to do this 17 times to get the more than 1,600 people who participated. So let's just write a quick loop to do that. We will just use a for loop, and we will go from 1 through 17, and we will do this call. And I suppose we should probably collect these repositories in some kind of variable. Yeah, a set seems to make sense, so we'll just create repos to be a mutable set of strings. Instead of initializing the variable here, we will just be adding to the set whenever we call get repositories. Now, I also don't want to hammer the GitHub API with a lot of requests in a quick burst, not 17 at once. So we are going to add a little bit of a delay after we make every repository's call. I hope that 2 seconds will be enough. And it obviously won't do that if we don't actually pass I instead of 1 here. Silly me. Okay. Okay, and we have hit an exception for exceeding the rate limit. I tried to be nice, I guess I wasn't nice enough. So there are 2 ways to do this now. Authenticated requests get a higher rate limit, or I guess we could just wait even longer. I don't want to deal with authentication right now, so I'm just going to up this to like 5 seconds, and then through the power of movie magic, you don't have to wait in agony to see whether this works like I do. So let's run this again and probably fast forward this part. Okay, it's growing. It's getting there. This is very exciting. I am thrilled. Wow. 900. And at 937, it seems to have crashed with a client request exception. And this time the problem is only the first 1,000 search results are available. Okay, well this kind of sucks because there is 1,600 of you out there who should at least be eligible to win a prize. And the API only gives me 1,000 results. What are these results ordered by? Default ordering is descending. Okay, here's an idea. And this is a trick that really just works because there's more than 1,000 participants, but less than 2,000 participants. What if we query the API twice? What if based on the sorting we take the most recently updated repositories, get 1,000 of those, and then turn it around and say, give me the least recently updated, get 1,000 of those, and then there should be some overlap in the middle, and that should be 2,000 in total, right? We should be able to cover a range of 2,000, which includes our 1,600. I like that idea. I think we're gonna build that one. Okay, so we do have an order parameter, which takes descending or ascending, and we have a sort parameter, which has stars, forks, help wanted issues, or how recently the items were updated. So let's probably change our sort to updated and our order to whichever one we need. All right, back to our code. We'll add the parameter sort to be of type updated, and we'll change the order to be, well, we need to make the call specifically based on repository, so we'll just pass this in as a string. Okay. So now if we make this query with ascending, we wait for 5 seconds, then we do descending, then we wait for another 5 seconds just to be safe. And then we also only need to do this 10 times, right? So with each iteration of this loop, we are getting one page, so 100 people who are the most recently updated, and then the least recently updated. And we add all of those to the actual set of repositories. Does that work? I hope so. Let's find out. Okay, there's 200. That's the first 100 who were most recently updated, and the 100 who were least recently updated. There's 400. I think we're onto something here, folks. I wonder what's up with this blockchain database, by the way, but again, we are going to have to do some kind of manual checking at the end to make sure that all the winners are actually eligible. Please don't implement advent of code on top of blockchain. Just don't. Thanks. Okay, 1,000. Moment of truth. 1,200. We made it over. Okay. 1,600. 1,602. That looks right. Okay, and now it's just doing a little bit of overlap work, but you know, we'll let it finish. You know, we'll let it do its victory lap just to make sure no one gets thrown by the wayside. There you go. 1,602 people. And these are all here in this wonderful long string. I suppose we could take this and just use a quick scratch file of type JSON, which is something that IntelliJ thankfully offers. And we can just auto-format this so that we can get a bit of a better idea. We can see, well, here's all the entrants who are eligible to get a prize. Nice. Now all that is left to do is to actually draw the winners, but we're gonna do that off screen for one simple reason. We gotta make sure that the repositories actually contain valid Kotlin code. We gotta make sure that people have contact information, and we gotta make sure that everything else is in order, so that they're not secretly working for JetBrains or something like that. It's Roman Yelizarov in disguise 10 times, who knows. But of course, this isn't live, this is a video recording, so I have the power of adding all the names of the winners onto the screen right here. Congratulations to all of you, we will be in touch to make sure that you get your Kotlin care package to you. But hold on, there is actually a couple more community rewards that we are handing out in the context of this campaign. First of all, a couple of people have really stood out in the Kotlin Lang Slack with how they helped other people get started with advent of code in Kotlin, and we really love to see it. So to these folks, a big thank you, and there's also a Kotlin care package coming your way. And I know we said it wouldn't matter how much or how fast you would solve things, but there's a couple of you out there who really have a competitive spirit, and despite us not having an official leaderboard, there was still a community leaderboard out there of Kotlin community members competing just for fun. And we figured in hindsight, why not throw out a couple of Kotlin care packages for those folks as well. Congratulations to these winners as well, we will be in touch with you too. Even if no care package is coming your way this year, I hope that if you participated, you still learned something new, you still had some fun, and you managed to challenge yourself. And as cliche as that may sound, I think in this regard we are all winners. With that, I'm signing off. I'm wishing you a late, happy 2022 and a lot of fun Kotlin code this year. Take care.